Welcome to another tips and tricks. In this demonstration I will cover normal maps and how to generate normal maps and height maps and be able to use those to render with mental ray using per pixel displacement to rebuild all the information that was saved into those maps. So this is a trick that's quite useful for video games. It's already used quite a bit, and we use normal maps in the viewport in the 3D engines. And you also use the height maps in order to do parallax mapping as a visual trick in the game engines. But when it comes to rendering, well, this trick allows us to actually use those two maps, the normal map and the height map, not only to trick visually, but also actually redisplace all of the information and rebuild the high polygon version. So what this means for game developers is that they can use their game asset, hit render, and be able to output from it a cinematic quality asset, and also a very useful trick for anyone like an architect or anyone else that's doing rendering and that needs to reduce the size of polygons, reduce the size of models. For instance, you could imagine in a Spider-Man movie how many buildings you have in the background. Well, this would allow you to have quite a few amount of polygons, but have really nice normal maps and height maps and be able to displace and recreate the detail at render time. So let's take a look at the model right now. This is our high polygon version of the model, and if you zoom in and orbit, you can see there's a bit of stuff in here. If we show the edge faces, this model, what we're actually going to do is take this high poly wall and the windows, the window frames, the door frames, all of that information we're going to mesh, we're going to collapse into one map onto low res mesh of this object. So if we take a look at the actual geometry that we're going to be doing, these little guys we're going to do separately. And let's just bring up our high walls plus windows, hide unselected. This is what we're actually going to mesh into the low poly geometry. So if we go into our polygon counter with this, we're going to have an idea of how big this is. It's not huge, but you can imagine that if this had complete brick detail kind of modeled right into it, and this would be pretty large. So we're going from 4,896 polygons, and we're going to put that on wall, and this is 220. So we're still going from roughly 5,000 to 200 polygons, which is significant for such a small little area. And let's go ahead and just bring out our we've got our low poly, sorry, here. And if we restore the normal map targets, this will give us both the high poly and the low poly that we're going to be mapping here. So in order to transfer this detail from one to the other, we're going to use a projection map. Now, we could do the standard technique that a lot of 3D applications out there use, which is just to do a ray trace between one and the other. But you can get some problems. For instance, here we would get an issue because if you do a standard ray trace, what would happen is that this face would be ray traced over to the other face, and if it's very, very flat like this going to this corner there, that detail's running at such a bizarre angle, it's almost tangent to this surface here, that we would lose a lot of the detail. This would not really come out very well. We've also got occluding surfaces. The side edges of the low poly is pretty much right on the high poly, so that would also cause issues, and that's a technique that's pretty standard in 3D. But luckily in Max we have a cage technique which allows us to sculpt the cage to get a better result out of it. So what we're going to do is start off by selecting the low poly version, like so. We're going to go into our rendering, render to texture, and this is where we have, amongst other things, we have a projection modifier available. Now you can set up the projection modifier, but it's built right in here, so that could make it a lot easier to just make sure you don't forget it. So here we've got the low wall, we've got the projection modifier, and we can go in and say pick. And this is where we're going to pick the high poly version. And we've got a selection set for that, so it's high walls plus windows, and that's basically everything that we have on hidden here, and say add. So what this did, this little process here, is the same as if I had selected the low poly, gone to modify, put a projection modifier on top, and in my projection modifier said pick list and picked those objects. Now we've also got here a cage. Right now it's hidden. I'm going to go ahead and show the cage and reset it. So this cage is now coplanar. It's exactly where the low poly mesh is. If you want to see it better, you can just alter the color of the low poly mesh, maybe going with a greenish color. This will give you possibly an easier display of that. So let's just go ahead and apply this green color to them. There we go. We also have here display toggle, so I can hide the reference or the working geometry. So here we can see in green, this is our low poly mesh, and in blue, that outer edge is the cage. Now the cage can be pushed out. You can do all sorts of stuff with it. What I'm going to do is unhide the high poly, look at the left hand side, so I just did L on the keyboard, and I'm going to take this cage and move it in order to encompass the high poly. So I'm going to have the cage, the high poly, and then the low poly version. So I'm just kind of doing, so here you can see actually that problem that we would have is this would ray trace from there to there, and I would lose a lot of detail because of the angle there. So because it's a cage, I can take these points and actually move them down and get something that'll be better. So in this case here, what will happen is it'll give me a much nicer solution because it will be projecting from here, getting all this detail here onto the other face. So that's really kind of what this this cage is really helpful for. So we've got that there. I'm also going to take this point right here, move that out far enough to get the tip here. I'll turn off shaded for now so that I don't have that overlay going on. So there we go. I'll grab this guy, move it a little bit. So really what I'm doing is creating a sandwich here. I want to have my cage, my high poly, and my low poly. There, we'll take this whole top part of the windows and doors and just move it down. This will allow us to have that kind of projection from there to there. Then I'll keep moving down lower, and let's see here. This one's a little bit far. I probably don't want this one all the way out there. There we go. Okay, and now let's just go ahead and grab all of this stuff and just move it out a little bit, like so, and then maybe move all of this up a little bit. And let's take the floor part here, move that up a little bit as well. And let's grab these guys. Let's take the whole bottom part. Just move them over to create that sandwich. So I want to grab these, move them up. Really just creating a good little sandwich between the two here. Move that up as well. And I probably want to move this just to make it sort of straight. That'll remove any type of weird distortion I may get because of an angle of some sort. Alright, so this is a pretty small angle. That's going to be fine all the way through. So I've got kind of the front aligned right. I do want to make sure that I take this whole back plate as well and move that forward like so. And I can probably move this one back a little bit now. So I'm just creating sort of a cage. Now if we go to a front view, we're going to do the same thing here. Right now, the top of these windows, you want to make sure that they're lowered. So I did lower those earlier. Those should be okay. Now the entire left-hand sides of these doors, so I'm going to just Control select all of these left-hand sides, and I'm going to move them in a little bit, like so. And then here you can do either a select invert, and then just remove the outer edges. That gives us the other side, or you could have just reselected everything. And I'll go ahead and move these in the other way, like so. So now if we turn this back on to shaded, this will allow us to really kind of zoom in and look at it. And if anything were flickering here, it means that we'd have a coplanar surface, so we'd have to go fix that. So we can just make sure that we've really got this kind of encompassed there, and we're good. This looks pretty good. Okay, so we're ready to do this, and we'll try it out. And what's great is that it's non-destructive, so if it does have a problem somewhere, it'll flag it with red, we can fix it and re-render it. So there's really no danger here. So we've got the projection set up. Let's bring our render to texture dialog back, and we've got this, we've got our projection. If I had set it up on my own here as a projection, when I'd come into the render to texture, I could select the little drop down and pick that projection. It might be a good idea to rename these. This way here you'll have that other name. Now we're going to bake everything using existing channel. I previously did it unwrap on the low poly version, so we're going to use that unwrap that I've previously done. We're going to do a normal map, diffuse map, and a height map. Now let's look at the values that we've got here. If we go into options, these are the types of mappings that we can do for the normal maps. Now you can use tangent, local, screen, or world, and you want to use tangent for characters or anything that's organic, anything that's moving and bending, because that will give us a normal map that is localized on the tangent space of the object, so it allows the lighting to be recalculated even if it's bending. Local XYZ is great for buildings, for cars, for anything that is not deforming, that's not bending, but is still allowed to move through space. So it's using the local space of the object itself. The other thing we want to make sure that we do is the height map here. Now the height map is very different from the normal map. The normal map is directional information, so this gives us a directional vector for the surface that of the high-res surface that's inside this cage. So that's just directional information, which means you'll move a light around and it'll look like the light is affecting the object correctly. The height map is the distance between the high poly and the low poly. And that information is important. If we're rebuilding the surface, we need to know how far to push that low poly pixel so that it matches up with where the high poly version was. One thing you can do is use the little probe picker here and start picking around, and you'll see values change. So we've got a -9 up here, and we can move up here and look at our different values. So we're going pretty much from like 7, maybe 5, 6, 7 in that area, all the way down to -10. There's a -10 there somewhere. So these values are important. So you just probe around, and then that'll help you set your values. So I'll go from -10 to +10. That should be fine. And what this means is it's using the units. It's going to use 10 units above and 10 units underneath the low poly. So if I've got my low poly object, 10 units, and in this case it's probably centimeters, so 10 centimeters in front of the object, it will probe for that high poly mesh, and 10 units behind. It's important to have these values very close to the reality of your high-res mesh, because if you put 5 miles on each, that means that your black value is going to be 5 miles negative from your low poly, and then this one would be 5 miles above. So all your detail, which would be within a few centimeters, would be within 2 or 3 shades of gray. So you really want to get this as close as you can to your actual model, because that will give you a lot more detail. And these values are important later on when we're going to do the rendering. So take note of them. So now we're ready to go. We'll bring our render to texture back in here, and we'll go ahead and just render this out. So I'm using certain names here. That's fine. You can change those if you need to. And I'll go ahead and hit render. Let's just overwrite these. Alright, so I'm going to spare you the render time. It's actually fairly quick. I might actually wade through it. Alright, so we're done rendering. Now if I go ahead and show you what the result is, I'll hide unselected. So this is my low poly. I can go ahead and get rid of the projection at this point, but you just want to do that if you're sure that it's okay. So what I do is just turn off the cage here, and that'll make it invisible. Now you can see our low res. It's right now displaying the diffuse map, which is red here in the bottom, and that's normal because our high poly version had a cutout at the bottom where the stairs were. And that's fine because the stairs I'm actually going to bring back into the shot, so they're going to go ahead and hide that portion there where that red part was. And that just means that it didn't hit a surface. So everything else is good. If I had red anywhere else, I would go and readjust the cage in those areas and re-render that map. Now let's go into our material editor and take a look at it. So let's go ahead and query this surface. I'll just grab this guy here, query the surface, and we've got here the baked material. I'm going to switch it over so that now if I render, it'll use the baked material. And that's just very easily done here. The reason you don't do this beforehand is because if there were a problem here, I wouldn't want the baked material being re-rendered into the fixed version of this. So by keeping it at render, I could re-render these normal maps as many times as I want, and that's fine. It's going to use the original material. But now that I'm happy with it, I can switch it over and say, okay, this is good. I'm going to use these values. So let's go into the maps here and see what it did. So it created a diffuse map. Not too interesting. I had nothing on it, so this is kind of boring. But if I did have some kind of a tiled texture of brick or something, this would be the map that I would bring into Photoshop to add in extra detail. And that's going to be the next step of this file. Then what we've got here is the normal map. So the normal bump is a wrapper that contains the normal map, and we've got our normal map right here. So this is a local XYZ space, and you can tell by the color. It would be mostly this kind of purplish blue if it were a tangent space. So here we've got our map, and what's cool about this is you could actually bring this in Photoshop. If you wanted to add an extra ridge somewhere, you could just clone a ridge that's there and just pop it right in, and that's extra detail. So you don't have to take this out of what what you've got there. You can go in and add detail. You can modify it. You can paint in this. You can do anything you want with these normal maps. I could even take some of these little things that are here and just copy them across the top here if I wanted to. So these are just maps. They're color information. Feel free to modify them and tweak them to your liking, to whatever your needs are. So we're also going to go into our other map, which is our height map. If I go and view it, we'll see it's grayscale information, and whatever was the most up front, which is the front of these columns here, is the whitest color, and then the darkest stuff is what was the furthest back, so it's the doors. So this looks pretty good as well. So let's go back in our material. Now the first thing I'll do is turn off the displacement. I don't want to use the standard max material displacement. I want to use per pixel height map displacement. So for now I'll just turn this off, and I'll leave the diffuse color and the bump map on. I'll bring the bump map up to 100 and then just go down here and say DirectX display in the viewport. Now because Max has DirectX built in, we're able to build a pixel shader on the fly that will display this normal map in the viewport. So let's turn off our edge faces here and look at it. So here it is with the normal map in the viewport. And if I bring out a light, so I'll just go and unhide my lights, and I do have a light that's set up right here. I'll just hit spacebar to lock it in and start moving it around. You'll see that the detail takes into account. You can see all those little door sills. All that stuff is not in the mesh. This is just a low poly. I'll show you the edge faces there. There's no edge there. So all that's just inside that texture, allowing me to get a nice amount of detail. Now the problem with these normal maps is that this is cool if you're in a video game, but if you're rendering this, you're an architect or just doing backgrounds for a movie, if you start looking at the angle here and looking at it straight on, well, this looks flat. It doesn't look right. Now if I were to render this without any displacement, what I would get is this problem here. Let's go ahead and render it. Now without any displacement, the lighting still looks cool, and notice I am using mental ray here, so the lighting will react correctly and that kind of looks good, but I don't have a real displacement. So I'll just go ahead and pause it for a second, and that it's perfectly flat here. So even though we've got the detail in the lighting, we're missing a lot of detail at render time. So let's go into our render RAM player, and I'll save out this image here for later use. Okay, so now if I want to add displacement to this, let's go into the materials. And here in the bottom we have a displacement map. Now if I use this one, I'm just using standard max displacement, which is just a standard value, which doesn't really give me that detail that I wanted. It doesn't give me the range, the -10 to +10 that I used before. So what you want to do is go down to the bottom in the mental ray connection, in the displacement slot, you want to turn off the lock and go in here and use height map displacement. So this is a displacement map that will give you those values that we used before. So we've got our -10 and our 10. So it's important to go in and put this. If you had -3 and +9, you want to put those values in there. And then go get that height map. So I'm going to go ahead and grab bitmap, and I'll just go to my other folder where these were rendered out to. And here we go. So this was low 9 wall height map. Alright, so now with this new height map value, it contains something that looks a lot better. So let's go ahead and hit render. So it'll take a little bit of while in the beginning because it's processing it. And then once it starts rendering, it'll go quite a bit faster. So here you can see how it's actually displacing that outer edge. We're getting detail here. We're getting it to actually move all the pixels, the right amount of vertices, the right amount of pixels away. So all that detail got rebuilt from that height map and normal map. So this means that you have something that's very, very close to the original high poly version, even though it's just a low poly mesh with a height map and a normal map. So this can help you cut a lot of corners and get some really nice stuff out of it. Now I have a couple other files in here you can load up. You can either open up the max file or just the finished file. If you open up the Courbet compare, this shows you a small object. Those are those little things that were on the wall. We've got the low poly versions here on the right hand side, and we've got the high poly version. And if you just show the finished material, that's the finished JPEG that's here, you'll see a comparison of them. So this will very easily show you that we've got the 47 polygon low poly version. This is just the wireframe. Then we've got the just flat shaded, and this is with the normal map on it. So it looks kind of cool, but you can still see the edges very flat, still just conforming to that old low poly version. This is the same mesh, but we are also using the height map on it. So very, very cool. We've got, again, 47 polys. This is the original object we use, 874 polygons. And we can see that we've got something that's very close to the high poly version, even though it's just 47 polys. So you could use this for doing all sorts of stuff. If you're doing environments, realistic environments, just build a fire hydrant that's really high poly, and then do this process, and then just merge that new model into any scene that you need to use it. Start building libraries using these normal maps and height maps, and you're going to save a huge amount of time. Not only can you now output these to maybe a real-time engine and be able to display them in all their detail, but also be able to render them faster, because you'll have a lot less polygons in the viewport, and just a few more textures. So this is a really nice trick to cut corners. And if you want to load up the finished version, once again, you can hit open, and there is a normals final. If you get up, you'll have everything in there with the normal maps. And there we go. So again, this is a low poly version, and you can orbit and get closer to it. There's a couple lights in the scene, so you can go ahead and move those around to see all the detail.